The South African Mathematics Foundation presents Olympiad Training with Professor Pillay. Don't forget to order your copy of Professor Pillay's book now. Go to www.samf.ac.za.
Good afternoon, all. Welcome to this first training session of the Senkoba training program for junior learners who have attained at least 50% in the first round of the Mathematics Olympiad. I want to congratulate all of you for having achieved this milestone. It is a start to bigger things. So in this program, we will be training you to tackle problems which are likely to occur in the second round of the Mathematics Olympiad, which is due to be written in May. I cannot remember exactly when, I think May 12th or thereabouts. And hopefully by the time we finish, you will have enough confidence to go into that challenge, with feeling quite comfortable in your own abilities. Now, the program consists of 4 sessions starting today, and it will finish on May, I think on the 4th of May. And it will always be at this time, Wednesday at 4 o'clock, and it will last for 2 hours. Sometimes I will go on for more than 2 hours. So I crave your indulgence for that, but you are always free to leave if you don't want to stay. I want to welcome also my good friend David Ramaboka, who is the chief organizer of this program. It was he who has written to you to invite you all to this session, and I want to thank him for all the hard work that he does in getting things together here. All right, since there is a large number of learners, we have over 200 people who are participating in this program at the moment. You would not have the privilege of talking to me. It will be chaotic, as you can very well understand, if you are allowed to speak with a large number of you speaking simultaneously, and I would not be able to handle it at all. So unfortunately, you will have to be muted, and you will have to bear the agony of listening to me for the next 2 hours. But at the end of that 2 hours, I will be happy to answer any questions. I will leave it open and I will unmute all of you. But at the same time, you can write down your questions on the chat column, and I will give that attention, prior attention, at the end of the program, so that I can answer those questions which are there already. I recognize a number of my good friends who are here, who have been with me previously. Welcome to all of you who have been here before, and also welcome to the new people who have coming into these Zoom sessions for the first time. All right, with those few words, we want to go on to the first session, which is going to deal with the 2018 round 2 junior Olympiad paper. And each Olympiad paper has got 25 questions in it. And yeah, each Olympiad paper has got 25 questions in it. And these, sometimes I might do the whole 25. We don't have the time to do everything. So unfortunately, we might have to stop every now and then. Today, for instance, we are not going to do the first few problems. We're going to start straight with problem 6. For some reason, my screen is not full. Okay, just one moment, please. I just want to do something here. David, I've tried to unmute you. Can you hear me?
Yes, now I can hear you. Can you hear me, Prof?
Yeah. David, my screen is not full. I don't know what I have to do regarding that. You can just help me with that, please.
What can you see? Can you see the icon? Is the
okay,
icon
I'm sharing it now.
on the left?
Yeah, you can see it's not full. It's just occupying a part of it. Oh, all right. Let me just make this longer. Okay, I think it's okay now. Okay, yeah. Thanks. All right, so the first question. Before I start, we give you the questions beforehand. My friend David Ramaboka sends the questions to you with about 3 or 4 days to spare. And I expect you to look through the questions before coming to a class. I've repeated this several times. You never go into a class without tackling a question beforehand. There's no point in knowing the answer to a question even before you have seen it. It makes no sense. So it was always, the questions go beforehand. Please try to do the questions. Those which you can't do, well, you will get the solutions in this class. And those that you can do, try them, and then you can check to see whether you're getting the right answers. All right, so with that, I just want to get to the first question. The first question is, a diagram shows a kite, A, B, C, D. Right? You should know a kite is a 4-sided figure with 2 pairs of adjacent sides equal. These 2 are equal, adjacent, next to each other, and those 2 are next to each other, they are equal. And in a kite, a kite has got various properties. I presume you know the properties of a kite, but I will quickly tell you. One of the things is that the opposite angles are equal. So these 2 are equal, angle B. If I call this angle B, if I call it X, then angle D is also X, right? So these 2 angles are equal. All right, so it shows a kite. What is the size of ABC? So the question is, what is X? So I've given a name to that, and I've called it X. So the question is, what is X? And to solve this problem, we observe that the 4 angles of a quadrilateral, any quadrilateral, add up to 180 degrees, 360 degrees. Okay, in a triangle, they sum to 180, but in a quadrilateral, it's 360. So you have an equation here because you can add these 4 angles, 70 plus 40 plus x, and those 4 angles, when you add them, at 360 degrees. Okay, and then you can solve for that. I think x equals 125 maybe. All right, so let's get on to the next one. This is a straightforward problem. You use property of a kite where the opposite angles are equal. If you want to know why they are equal, what you can do is you can join this diagonal. And when you join this diagonal, you will get two triangles which are congruent. You can see this equals this equals this, and this is common. So these two triangles are congruent. The reason for congruency is side, 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 three sides, and therefore these angles are equal. And likewise, even these two angles are equal for the same reason, they're congruent, and these two angles are equal. So in words, you say that one of the diagonals bisects the opposite angles. Both the angles are bisected. More than that, when you join this diagonal here, you will see that this line is perpendicular to that. The two diagonals are perpendicular to each other in a kite. Okay, and one of the diagonals is actually bisected. This shorter diagonal, in this case, is actually bisected, and you have that these are equal. Okay, so these are the various properties of a kite. This is 90 degrees. All right, so let's just get on to the next problem. We will be going rather briskly, simply because we've got many problems to do in 2 hours, and I want to try to finish the whole, go up to 25. It becomes more and more difficult as we go along. So in the beginning, we'll have to go very quickly. The solid was made by gluing together 4 identical cubes, as you can see, each with side length 1. What is the total surface area of the solid in centimeters? So this question here asks, what is the area which is exposed? Right? The area which is exposed, they are glued here, they're glued here, and they're glued here. So the surface area will be the area of the exposed part. You can see that there are only 3 which are covered. Here there is a side, a surface which is not counted. There too it's covered, and there like that. So 3 of them are covered of all the faces. And how many faces do you have? Each cube, a cube has got 6 faces. Any cube has got 6 faces. You call these faces. This one here, 1, 2, and then one at the back, 3, 4, one at the bottom, 5, and the one opposite this is 6. So you've got 6 faces. And altogether in 4, you got 24 faces. 6 times 4, and of these 3 are covered. So the total number of faces which are not covered is 21, and each of those faces, the sides are all 1 centimeter each. So all the sides are 1 centimeter. So each side, each face has got area 1 square centimeter, and there are 21 such faces. So therefore the answer is 21 square centimeters. All right. The other way of doing it is that doesn't seem to be right. Okay, why did I go wrong? Sorry about this. The back face, there's only 1 face which is covered. There are 5 exposed faces there. Here there are 5 exposed faces on the side, and here too there are 5 exposed faces. That makes 15, and there are only 3 here. So this is wrong. So there's some logic which went off here. I'm sorry about this. So you got 5 exposed here, 5 exposed here, 5, and you got these 3 faces. So you got 18 square exposed faces. The answer is 18 square centimeters and not 5, because it seems to me that there are 6 faces which are covered, because here there are 2 faces here, you see. That one has got 1 face and that one face. So there are 2 faces blocked here, there are 2 faces blocked here, and there are 2 faces blocked here. So I should have subtracted 6 from 24, not 3. And that is why I went wrong. Okay, but it might be better to just see which faces are exposed, the 18 of them. And each one has got area 1 square centimeters. Okay, so let's just get on to the next problem, which is this: the sum of 4 consecutive whole numbers is 2018. Find the smallest of these numbers. So this problem says there are 4 numbers which are consecutive. Consecutive numbers, they all differ by 1. So if the smallest one, we don't know what these numbers are, and the question is, what is the smallest? So you give a name to the smallest. So let x be the smallest of these 4 numbers. All right, so the 4 consecutive numbers are x is the smallest. The next one is x plus 1. The next one is x plus 2. They're consecutive, so you keep adding 1 to it. And you're adding the 4. So the sum of these 4 equals 2018. So you have an equation. In mathematics, you try very hard to come to equations because you know how to solve equations. They teach you, spend a large time of school mathematics teaching you how to solve equations. And once you come to an equation, the rest should be easy. So the idea is to create equations from what is given. And here you created the equations. You got 4x, and you got 6 goes to the other side. So it's 2018 minus 6, which is 2012. And x, which is the smallest, is 503. So that's the answer to the question. X is 503. Okay. All right. So the next one is, as I said, I'm going to go rather briskly because I want to finish all 25. And these early ones, we don't need to spend too much of time over because you can, I'm sure you will be able to understand them. Okay, so the next question is, how many 2-digit numbers odd numbers can be made using the digits 1, 2, 3, 4, 5, 6, 7, 8 if each digit can be used only once in a given number? All right, let's just take it a little bit easy on this because this is a kind of problem which occurs often where you have to count. The question is, how many? So many questions are like that. How many? Preceded by how many? So now we have to figure out a way of actually counting these things. Now, what are we counting? We're counting 2-digit odd numbers. So you're counting numbers which have got 2 digits like that. And it's an odd number, which means that the units digit is odd. For a number to be odd, the units digit is odd, right? Because if the units digit is even, the number is even. You all know that. So the units digit can be only an odd number, and the odd numbers here are these numbers. Could be 1 or 3 or 5 or 7, right? So these, the units digit is one of those 4. Now, yeah, what can you put in the first digit? If the units digit is 1, let's take each one. If the units digit is 1, what can you put here? Right? They say that each digit can be used only once in a given number. So this part here now kicks in. So you got 1 here, you're not allowed to put 1 again, but you can put any number you like except 1. And there are 8 numbers here, right? So you can put any one of 7 numbers, but not 1, right? So here there are 7 numbers which end in 1. The same argument will tell you that there are 7 numbers which end in 3, and 7 numbers in 5, and 7 numbers end in 7. So altogether, the number of numbers you have, because if you list the whole lot down, which we are not going to do, we can actually count it in this easy way, is actually 4 times 7, which is 28, or 7 plus 7 plus 7 plus 7, right? So you can actually count them. Here, the odd numbers associated with 1 are, let's say now, it's not 11, but it's 21, 31, 41, 51, 61, 71, 81, because 1 cannot be used. So that's 7. Here you have 13, 23, 43, and so on, right? That's 7 there. So altogether, there are 7 plus 7, which is 4 times 7, which is equal to 28. Now, the reason why I made an issue of that is there is another way of doing this, and some people will be aware of that method. What I do is I count in a very specific way. I say I need to fill 2 blocks. This is your tens unit, and the other is your Liam, can you please put your hand down? I will answer questions at the end of the class. And when you if you raise your hands, you're blocking my screen. So please don't do that. And Charmaine, you also, please, let me just make this announcement once. When you raise your hand, you're blocking my screen and I cannot work. Write down your question in the chat column, and I will address that question at the end of the session at 6 o'clock. Okay, then I will allow you to talk to me and raise those questions. Right now, I cannot talk to you. There are over 200 people here in the classroom. Okay, let's just get back to this question here. So you got a tens unit, a tens column, and you got a units column. There are 2-digit numbers, right? And you say the units digit can be chosen in 4 different ways. Right? You can see it's only 1, 3, 5, 7. So I put the 4 here to say that the units can be chosen in 4 ways. Right. Now, in how many ways can the tens be chosen? Right. There are 8 altogether. I can put any one of those 8 except the one that I put here. So therefore, the tens can be chosen in 7 ways. And the final answer is you simply have to multiply these 2 numbers, and the answer is 28. This is a very nice way of counting, right? Where you fill in, you put a blocks here to say, I want to fill in some blocks, empty blocks. How many ways can I fill each of those blocks and multiply the whole lot together? And that will give you the number, the count for the problem, okay? We will come across those in future, but just remember that this is the strategy, right? You have empty blocks and you say, fill in each empty block with how many ways can you fill that block, and so on. And then you multiply the answers together and you can get to your final answer. Okay, so the next question, we are now in question 12. Okay, this problem says the 6 angles of 2 different triangles are listed from largest to smallest. Okay, if you got 2 different triangles, each triangle has got 3 angles. So there are 2 triangles, so there are 6 angles altogether. So the 6 angles are listed from largest to smallest. The 2 smallest angles have been left off the list. So you got that 120, 80, 65, 37. There are 2 more and they've been left out. And the question here is, in degrees, what is the last angle on the list? Okay, it's a very nice question. So let's just analyze this question. I'd like to draw my 2 triangles first. Right, so I know where I'm going, so I can see my 6 angles. So there it is. I've got my 2 triangles, and these are the angles which are given. Now, one of the triangles has got 120 in it. All right, so let's have a look at this triangle here. in this triangle, these two angles here, they both add up to 60 degrees because the three angles add up to 180. So these two add up to 60 degrees, which means that both of these are smaller than 60 degrees. So these angles here cannot be in this triangle. This triangle here, it has to go into the other triangle. It can't be in this triangle because these two add up to 60. So each one must be smaller than 60. These two are bigger than 60. Now, once you have this picture, you can do the rest because you've got two angles in this triangle. So therefore, you can calculate the third angle, right? You add these two, you get 145, subtract from 180 and you get 35. So this is 35. 35 is not here. 35 is not here. So therefore, 37 is here. And now if that is 37, then you can see what the third angle will be. These two add up to 157 and all three add up to 180. So this has to be 23 degrees. So the two new angles which you have drawn are 23 degrees, 35 and 23, and you can see they are the two smallest angles in this list. Okay, so the answer to the problem is they wanted to know what are the remaining two angles, or what is the smallest angle. So the answer is 23. That is the smallest of the lot. So you have to read the problem, understand it, and draw a picture. This is what we have done. We've drawn a picture so that we can try to interpret the question in the picture. And the only thing we use here is that the sum of the angles of a triangle is 180 degrees. Logically, you can decide where these angles go, as I did, and thereafter you can make your conclusions. All right, so that is the solution to that problem. Now we're going on to a little bit more complicated kind of problems now. We are now going to problem number 13, right? And here you've got three circles and they all touch each other. Okay. These three circles, they all touch each other, as you can see. The word for touch in geometry is tangent. You have a line can touch a circle, or you can have circles which touch another circle. It means it cuts it in exactly one point, right? So it just touches it. So yeah, you have two circles which are touching each other. And what else do you have? They said the vertices of a 3, 4, 5 right angle triangle ABC. So this triangle here, when they say 3, 4, 5, it means the sides are 3, 4, and 5. In fact, they give it to you here. The sides are 3, 4, and 5. And then you've got these circles. Now determine the sum of the diameters of the three circles. So we've got the three circles. Each circle has got a diameter. And the question is now, what is the sum of the diameters? Okay, so I've drawn this diagram here. I made it a bit larger. And we have that AB is 3. This thing here is 3. The AB, and AC is 4. So that is 4. And BC is 5. And now you need to know what is the sum of the diameters. All right. Now you can see the radii here. So I'm going to give names to the radii. The distance from here to here, let's call it X. That's the radius of the circle from here to here. And that's the same as this. Because in a circle, all the radii are all equal. So if I call this x, this will also be x. Now from B, if I call this radius y, right, from here to here, then this is also y. Radii are equal. And here, if I call this z, this is also z for the same reason. So we are asked to find the sum of the diameters. I've given the names x, y, and z to these. So the question is, the diameter of this circle, circle A, the circle center A, the radius is x, so it's 2x. That's the diameter. The diameter of circle B is 2y, and the diameter of circle C is 2z. And we are asked to find the sum of the diameters. So we take these two diameters, the three diameters, and we want to know what is this value. The question is, what is that value? Okay. All right, now what do we have? We have that AB is equal to 3. So you've got that. Now there is an important fact here. I didn't emphasize this. I'm just kind of assuming this. And the assumption I'm making here is that the center of A, the circle, the center of B, and the place where they touch, they all lie on the same straight line. Can you see? There are 3 points here. You know, got 3 points, they need not lie on the same straight line. But I'm assuming that these, the points where they touch, that one, that one, that one, and the same thing with this, they all lie in the same straight line. And I need to explain why I can make that assumption. So I'm going to take a little bit of time. If you've got two circles which are touching, right, I'm going to explain why the centers and the point of contact, what you call the point of contact, why they all lie in the same straight line. So suppose this is the center here, and this is center here, and this is the point of contact. Now, how do we know that all these three lie on the same straight line? Okay. Now, before we can do that, we need to say something else, and that is, when you have a tangent to a circle, okay, Sponga Kumalo, please put your hand down. If you've got a tangent to a circle, now a very important fact about a tangent to a circle, the place where it touches the tangent, touches the circle, I'm sorry. To me, so will you please put your, can I just say this for the last time? There are people who are raising their hands. Don't do that because you are blocking my screen and I cannot see what I am doing. Please refrain from raising your hand. I was saying that when you got a tangent, this is a tangent is a straight line which touches the circle in exactly one point. So when you join the center of the circle to the point of contact, in other words, where it touches, right? It's a well-known fact that this line here is perpendicular to this, that this angle is actually 90 degrees. The tangent is perpendicular to the radius at the point of contact. It's a very important fact. So in this case here, what I will do is I will draw at this point of contact, there is a tangent, which is the common tangent. It's a tangent to both the circles. Right? If I draw a tangent to one of the circles, it's also tangent to the circle. And then you can see that when I join these two, I'm going to get 90 degrees on this side, and I join these two, I'm going to get 90 degrees on this side. So the angle here is 90 plus 90, which is 180. That is why this becomes a straight line. Each of these is 90. So these 3 points all lie in a straight line. This angle here is actually 180 degrees because it's 90 plus 90. And that's why it's a straight line. So I was trying to explain why I'm saying that all these points are in a straight line. Okay, so let's just go on with this problem. You've got AB is x plus y, and that is 3. It's given. AB is 3. AC is x plus z. That's AC, and it's given that AC is 4. And BC is y plus z. It's given that's 5. So how am I going to get this 2x plus 2y plus 2z? Well, if you look at these, you can see on the left-hand side, I got 2 x's, I got 2 y's, and I got 2 z's. So why don't we add everything? Add both sides. So straight away, when you add them, you'll get 2x. There are 2 x's here, there are 2 y's here, and 2 z's. So you get the answer straight away. This must be equal to 3 plus 4 plus 5. So you got on the right-hand side, and that's 12. So the answer to the question is 12. Okay. Yeah, I just want to explain why I don't want to speak to any one of you. There are over 200 students. And if each one of you starts asking me questions, we will never be able to finish everything. I'm going to give you an opportunity to ask the questions at the end of the session. When I finish problem 25, you can stay back and you can ask me questions and I will answer them. I will give you the opportunity to talk then, but not now. Right, so let's just get on to the next problem. Problem number 14. Says that Skylar, there's somebody whose name is Skylar, she's sewing together a rectangular quilt. Okay, even if you don't know what a quilt is, what we are saying is that it's rectangular. It's a rectangle. So the quilt is like that. And it's 1.5 meters long and 1.2 meters. So it's 1.5 on one side and 1.2 the other side. The quilt is that. And it's made from square pieces of fabric, each measuring 15 centimeters by 15 centimeters. So it's made up of a lot of small pieces, which are all squares, because they are 15 by 15. If you look at any one of these squares here, like that, it means that each side of the square is 15. And these are in centimeters and these are in meters. Well, let's convert to centimeters. 1.5 meters is 1,500 centimeters. 1 meter is 100 centimeters. Yeah. And this too is 150 centimeters, 120 centimeters. 1.2 times 10 is 100, times 100 is 120. So there's 150 centimeters here and 120 centimeters here. So if there's 15 here, it means that the 15, how many 15s are there in 120 to find out how many along the length. So you'll have to divide 120 by 15. So what is that? 5 goes into this 3 times, 5 goes into this 24 times, 3 goes into this 8 times. So the answer is 8. So the 8 pieces on this side of the small piece along this. And, oh, I'm sorry, that's on this side. 8 on this side. Divided by 150. 120 at least. And in the other case, it's easy to see there are 10. Okay, so there are 10 pieces on this side, there are 10 pieces on this side. Okay, at every point where where 4 squares meet, Skylar plans to sew a bright button. How many buttons will she need? All right, now you got a lot of lines which are drawn like this. And like for instance here, and sorry, you got another one down up here like that. And there are four squares meet at this spot here. So there are many places where 4 squares meet. At each one of those points, she wants to sew a button. And the question is, how many buttons does she sew altogether? So let's just get to my next slide, where I've drawn a small situation here. You can see the buttons are at these holes. Right, so there are no buttons on the edge here, but only the buttons inside. So how many buttons are there altogether? So we have to see how many buttons are there along this. So you got a grid of buttons, right? What do I mean by that? You got a number of in the first row. Now remember, we had 15. I'm sorry, we had 10 pieces here. We had 10 pieces. And how many buttons have you got along the row? You don't have 10. The reason is you'll have a button here, but there's no button there and there's no button there. So if you count the number of buttons here, this square here will have one in its right top corner. That's 1. This will have another one. This will have 1 here, right? And the last one doesn't have any in the top right hand corner. So although there are 10 pieces, there are only 9 buttons. So there are 9 along the horizontal, because there are 10 this way. And this way you had 8 of those pieces. And again, you'll count buttons along in this exactly the same way, but you don't get 8 buttons vertically. This time you'll have only 7 buttons for the same reason. And the total number of buttons, you can see there are 7 rows, each one having 9 buttons. So the answer is 9 times 7, which is 63. So this problem, if you see the way I've done this thing, and it's advisable to take a problem and dissect it piece by piece. I read this, I say rectangular quilt, and I digest that information. Then I say it's 1.5 meters by 1.2 meters. I digest this information, I draw a diagram. And then here you say it's made up of square pieces, 15 centimeters. Then I put a diagram and then I analyze that. I say, okay, how many pieces do I need and so on, even before going on to the next question. And having done that, now I'm getting a better understanding of the question. And then I look at the next part. And that, by the time I get there, I will understand what it's all about. But if you read the whole question and come to the end, it'll just be gibberish. So don't do that. You must, in any problem, do it piecemeal, line by line. Sometimes you can't do that, but if you can, go ahead and do it, and then you can understand the whole story. Otherwise, you'll be very confused. So you do it like piece by piece. Okay, so we get to the next problem. problem number 15. In the sum below, each letter represents a different digit. So A, B, C is a 3-digit number. So this is a 3-digit number. This is not a product. It's a 3-digit number. All right, so each number, it's important to say each letter represents a different digit. So you can't use the same digit for A and B, for instance. You have to have different digits. Okay. Now, so when you add these two, you're going to come to BCC. And the question is, what is the digit A? They don't tell you what these digits are. So you have to analyze this thing and see, well, let's see now, when I'm adding, how do I add? I will add these two. And when I add these two, I get the same number. Is that possible? If you add 1 and 1, you won't get 1. 2 and 2, you won't get 2. So which one will give you the same number? There's only one number which can be added to itself to give you the same number. Even if you might think 5 and 5, but that gives you 10. That gives you 0 there. So that doesn't work. So the thing that works is C equals 0. See? So so now we have that C is 0. So let's just put a 0 here. We put a 0 here. And let's see, there's a 0 here and the 0 here. All right, so now I'm adding 0 plus 0 is 0, nothing to carry over. Now these two digits, when you add them, you're going to land at 0. The only way that can happen is, this is 5. Right? 5 plus 5 will give you 10, land at 0. So this has to be 5. So you're carrying 1 now. Right? But this number here is B. It's the same as this. B. So this is 5. Right? Because these two are. Now I'm carrying 1 and you're adding these two numbers. That's the same number. And 1 plus this plus it's repeated is 5. So the sum of these two is 4 and they are both the same. So they will have to be 2 each. So the digit A is actually equal to 2. All right. I'm going to send you recordings of this. So in case you think that we are going too fast, you can always check the recording, stop it, and think about what I am saying, and digest it and go on to the next one. So now at the moment, we don't have the luxury of stopping anywhere. So here you can see I've calculated each one of them step by step in a logical way, and I came to the answer A equals 2. So let's get to the next problem. All right, the next problem says the average of U and V are 200, is 200. Okay, so now in this case here, we need to know what you mean by average. Right, so let's interrogate that. So how do you find an average? Let's analyze that. If I ask you to find the average of 5, 7, and 12, how would you do it? Well, the process is if you got to find the average of a collection of numbers, you add them and divide by the number of numbers you've got. And here you see you got 12 plus 12 is 24, and the average is 8. Right. Now, what does this mean? It means that to find the average, you add them and divide by the number of numbers. But one very important thing here is that 5 plus 7 plus 12 is 8 times 3. Right? You can see when I'm dividing this by 3, I get 8. So the sum of the numbers, this is very important. Sum of numbers equals, this is the average multiplied by how many numbers you've got. In this case, there are 3, but it's the number of numbers. If there are 4 numbers, you multiply by 4. So the average is part of an equation, you see. So when you got the average, you can write an equation. But that is the moral of the story. Okay, now if you apply that principle to this, the average of U and V is 200. So from that, we are saying that the sum of the numbers, which is U plus V, is the average times how many numbers do you have? 2, U and V, so that's 400. Right. So taking the first part, see, I didn't read the rest of the question. I'm just taking the first part and I'm analyzing what do you mean by the average. And with that, I have an equation. Now that's very important. If I've got an equation, you know, I'm getting somewhere. The second part says the average of X, Y, and Z is 150. And the same thing you do here, it means when you add those 3 numbers, you're going to get the average is 150. So it's going to be 150 times how many numbers do you have? 3. Right. So that's 450. Right. Now the question is, there's a question. Determine the average of U, V, X, Y, and Z. So now you need to find the average, right? So what do we need to do? We need to add those 5 numbers, U plus V plus X plus Y plus Z, add all of them and divide by, how many numbers do you have? 5 numbers. Divide that by 5. You want to know, what is this equal to? Now here we've got down our 2 equations and we need to work out this. But you can see very quickly that you got U plus V here and you got X plus Y plus Z. And I can get this thing at the top by simply adding on both sides. So if I add this and that, I will get what I want. Right? If you add these 2, what do you get? Now, according to this equation, this plus this is equal to 400 plus 450. And that is 850. But we need to work out the average, so we need to work out this divided by 5. So it's this divided by 5. So it's that divided by 5. And when you divide 850 by 5, you get 170. So that's your answer. You see? I take the information, get equations, and then say, what is the question? It's very, very important. What is the question? Okay, the question is to find the average. How do you find the average? Well, to find the average, you have to add all the numbers and divide by 5. And that is what I need to find. And once you know where you are heading, then you can look at what you've got and say, well, let's see, can I get to this? And you can see very quickly that you simply can get to that by adding on both sides. Okay, let's get to the next question. Now we're going on. As it goes deeper and deeper into the question paper, you will see that the problem is becoming more and more challenging. But in each case, there are ideas. And you'll notice most of the time we are speaking about ideas which you're already familiar with. The angles of a triangle, or the average of numbers, or how to count, what do you mean by an odd number, and so on. These are all well-known ideas. So but in problem solving, you have to figure out a method of answering the question. This question here, let's have a look at this. Some numbers, when divided by 6, leave a remainder of 5. All right, let's just analyze that. So when you divide by 6, it leaves a remainder of 5. Which numbers do that? Well, 5 itself is such a number. When I divide by 6, the remainder is 5, obviously. Okay, the next one is 11. right? When I divide this by 6, the remainder is 5. And you will see that the next one will be, you have to add 6 to it. So you get 17. If you divide this by 6, 6 goes into this 2 times, remainder 5. So you keep adding 6s. And all these numbers, there are many numbers, which when divided by 6 gives you a remainder of 5. Now, but when divided by 5, it leaves a remainder of 4. So we can start with 4, because 5 goes into 4 0 times, and the remainder is 4. And this time you add 5s now. When you divide this by 5, the remainder is 4. You keep adding 5, 14. Keep adding 5s now. Okay, this sequence is nice, 24, 29, 34, 39, and so on. All right, so this is the second statement. So we finished with this. We finished with this. When divided by 4, it leaves a remainder of 3. So the remainder is 3, but now you are dividing by 4. So you have to keep adding. Right. The question is, you want one number which satisfies all 3 conditions. That number, when it's divided by 5, it's remainder, divided by 6, it leaves the remainder of 5, and so on. So you want a number which is here, and here, and here. If you look at it now, as it stands, I can't see any numbers which are in all 3, right? So we don't know where these numbers are, but they want the smallest such number. So if you want to solve this problem, you can go all the way and do all the way and do all the way and see when you get one number which occurs 3 times in all 3. And that number will satisfy all those 3 conditions. But you want the smallest one, so you want the very first one, which will be in all 3, what you call sequences. These are all sequences. Now, one interesting thing here is that you'll notice that the remainder of 5 is 1 less than 6. And the remainder of 4 is 1 less than 5. And the remainder is 3 is 1 less than 4. Now that gives a clue here, which is not very easy to see. But you'll see that if I add 1 to all these, I get multiples of 6. You get multiples of 6. Because the remainder is 5. So if you add 1 to it, it becomes a multiple of 6, you see. So you get 42, 48, 36, and so on. So if I add 1 to all these numbers, I'm going to get a multiple of 6. Now here, we were dividing by 5. So when I add 1 to each one of these, so I got 5, 10, 15, 20, 25, 30, 35. I'm going to get multiples of 5. And here, divide by 4, the remainder is 3. So here, if I add 1 to each of these numbers, you get 4, 8, 12, 16, 20, 24. They all become multiples of 4. Sorry for the bad writing. Multiples of 5, multiples of 6. So what happens here, we see that the number that we are looking for is going to be, firstly, a multiple of 6, and also a multiple of 5, and also a multiple of 4, but less 1. Then it will be in all the sets. And you want the smallest such number. So you're looking for the smallest single multiple of 6, 5, and 4. So the question is, what is the smallest number that is a multiple of 6, 5, and 4. Now that's the LCM. See, lowest common multiple. It must be a common multiple of these 4 numbers, 3 numbers, and the smallest, so it's the lowest common multiple is LCM. And the LCM of 6, 5, and 4, when you work it out, you know how to calculate the LCM. You'll see it is 60. So when I add 1, I get 60. So the number we are looking for is 59 here. Okay? And that will be here as well. You can see 34, 39, 59, and is also here. In all these cases, 59 plus 1 is a multiple of 4, multiple of 5, and multiple of 6. Okay, so the answer that we're looking for is the LCM is lowest. So it's 60 minus 1. Why? Because when I'm adding 1 to these sequences, so to get to that sequence, I have to subtract 1. Okay, so that's a very challenging problem. But now that is problem number 17. So you can expect this kind of a thing as we go along. And the next problem, let me just go over this thing again, because it is a rather difficult problem. So when we read this problem here, we see that using this information, you can list the 3 sequences. There are many numbers which, when divided by 6, leave a remainder of 5. There's a whole lot of them, infinitely many of them. When you divide by 6, you leave a remainder of 5, and you can list all of them down. It forms what you call an arithmetic progression. You can see arithmetic sequence with first term 5 and common difference 6. And here too, you have, when you divide by 5, all the numbers which leave a remainder of 4, they also form an arithmetic progression. Common difference is 5, first term is 4, and likewise this thing. But let's not worry about arithmetic progressions and all that stuff. What we are saying here is that I want one number which is in all these 3, and what is the first number? And then that wasn't very easy to answer. But I saw that instead of saying the remainder is 5 or 4 or 3, I can make it a single kind of remainder, but by saying that in each case, if I add 1, I'm going to get a multiple of that thing. And that's a tricky observation. See? If add 1. Because 5 is 1 less than 6, 4 is 1 less than 5, 3 is 1 less than 4. So that gives a clue, right? And then once you do that, then you suddenly see that you're looking for the smallest number, which has the property that is going to be a multiple of 6, 5, and 4 minus 1. Okay, so let's so the next question. This is a kind of tricky question. I myself kind of struggled with this problem here. The diagram shown contains 41 identical squares. So if you count all of them, you'll see you've got 41 small squares. Some of the squares are shaded, as you can see. Now, what is the least number of squares that still needed to be shaded for the diagram to have a line of symmetry? So you need to know what you mean by a line of symmetry, right? A line of symmetry is, it's like a mirror, see. If you take a kite, for instance, and you join those two, this is a line of symmetry. The reason is, if you regard this as a mirror, and this triangle is looking at itself in the mirror, this is what it will see. So it's a mirror image. The one part is a mirror image. So this line goes to that line goes to that, and the line of symmetry is the mirror itself. So you want to know which lines are the mirrors in this shape. Now, there are actually 4 such lines, and I'm going to show them to you. This red line here, I'm going to put an arrow here, this line here. You can see that's a line of symmetry. Now you can have this line here is also a line of symmetry, but it must be halfway in between here. The reason is you got 2 squares at the top, 2 squares at the bottom. So this is halfway in between here. But there's another one here. You see this diagonal one like this. That's also a line of symmetry for the figure. And this thing here as well. So there are actually 4 lines of symmetry in this picture. Now, what is the question? The question says, I have to shade in some squares to make this a line of symmetry. At the moment now, for example, this line is not a line of symmetry, but I can make it a line of symmetry if I shade in the following squares. Let's have a look at this. We are focusing on this line here. This vertical line. Okay, this is fine. These 2 are fine, the mirror images. But here, this, I need to shade in that part there. And this thing, I need to shade in that part. So I have to shade in 2 things here. And here, this part is fine. This thing, I have to shade in that to make that symmetrical. This is fine. And here, to shade in there. So I have to shade in 4 squares here for this line. 4 squares have to be shaded. For this line here to be a line of symmetry. Now like that, now in each one of those, you can shade those lines and ask yourself, how many squares must you shade? Because the question is, what is the least number of squares that still need to be shaded for the diagram to have a line of symmetry, right? So I saw that you have to shade in 4 if you want the vertical line. And like that, for each one of them, you can shade in. And you will see that this line here is the one that has the least number. This line here. I told you that this line of symmetry. And there are only 3 squares which you have to shade to get this to be a line of symmetry. Right? We saw that there were 4 in that first case, and you can count the others in the other 2 cases, and you will see that they are both of them greater than 3. So this is the only one, this is the one with the lowest number of squares that need to be shaded. So the answer is 3. The least number of squares that you have to need to shade for the thing to have a line of symmetry is 3. If these were shaded, then this picture here has got a line of symmetry. Right? So that's the answer to that question. Okay, go to problem 19 now. We are at that level. Problem 19 says, star of x is the sum of the digits of the positive whole number x. Now this funny looking thing here, now you have to ask yourself, what is the meaning of this? It's a very strange looking object, but they tell you the meaning. So this star and x is a positive whole number. So let's put a positive whole number like 73 here. Right. So in place of x here, if I put 73, so we'll read this as star of 73. Now what is this? It is the sum of the digits of x. So what is the sum of the digits of this number here? That's your x in this problem. I've replaced x by 73. The answer is 10. 7 plus 3. So like that, you can work out the star of 256 is 2 plus 5 plus 6, which is 13. So it's easy. What is the star of a number? It's the sum of the digits. They tell you what the meaning of the star of a number is, the sum of the digits. See, I've just read the first part and understood it, and now I go to the second part. For example, star of 8 is 8, star of 123 is 6. I've already given those examples. Okay, we've seen it. Now, for how many different two-digit numbers is star of x equal to 3? Oh, you got a double star now. That causes a problem. So what do you mean by a double star? So I got star of this is 10. Now I have to work out the star of this. Oh. A double star of this is the same as star of 10. And we just saw that the star of a number is the sum of the digits. So the double star of 73 is 1. Now what is the double star of 256? That will be the star of 13, and that's 4. So to get the double star, you have to add the digits, get the answer, and add the digits of that. So you get the double star of some unknown, and the answer is 3. Okay, so I've got 1 in this case, and I've got 4 in this case. I don't have 3 in either case. So the number that we're looking for, x, is not 73, and it's not 256. So they want to know how many two-digit numbers. Okay, you don't have to worry about that one. How many different two-digit numbers x is star of x equal to 3? Okay, so we have to think very carefully about this. But you have to understand what you mean by this. This is, you take the star of x and you add the sum of the digits, and then you work out the sum of the digits of that, and you get 3. So let's get to my okay, so I've got some space here for me to work with. All right, the first thing I notice is that, let's see what this means. Star of x equals 3. What is the meaning of this? It means that the digit sum of the stuff inside is 3. It means what we call the digit sum. I'll call this the digit sum. The digit sum of 123 is 6. Right? So the digit sum of this thing here, star of x, is 3. So you have to understand that. Okay. So what does this mean now? If the digit sum of star of x is 3, let's see which two-digit numbers the star of x, I want the digit sum to be 3. So which two-digit numbers have got the digit number 3? Well, you can have 12, 21. You can have 3 as well. The star of x could be 3, or the star of x can be 21. Are there any others? There's also 30. So then the digits could be either 1 or 2, 1 plus 2, It could be 2 plus 1, it could be 3 plus 0. I don't think there's anything else. These are the only 2-digit numbers. You'll ask, why have I allowed that one? Because they say that X is a 2-digit number, right? We still don't know the X is a 2-digit number, but they didn't say the star of X is a 2-digit number. So that is why we have to say the digit sum of this, we can allow 3 in this. Because these are the possibilities. And the other interesting thing is that X is a 2-digit number, right? So star of X, what is the largest possible value of star of X? Right? In other words, of all the 2-digit numbers, and if you add the digits of a 2-digit number, what is the largest possible value you can have? What is the largest digit sum of a 2-digit number? Now, if you think about it, you'll see the largest 2-digit answer that you can get is from 99, right? Because each digit is less than or equal to 9. So star of X is always less than or equal to, the largest one is 18 for a 2-digit number. If X is a 2-digit number, the largest value of star of X, which is the sum of the digits, is 18. Now we got star of X equals this, so that immediately eliminates that one. Star of X can never be 21. The star of X can never be 30 if X is a 2-digit number, right? Because the largest possible sum of a 2-digit number is 18. It can't be 21, it can't be 30. All right, now you got star of X is 12. And you want to see which numbers, which 2-digit numbers have the property that when you add the 2 digits, the answer is 12. Well, the first digit can't be 1, right? Because you want the sum to be 12. The smallest one you can have is 3. 3 plus 9, 48, 57, 66, 75, 84, 93. In all these cases here, you have 3 plus 9, 4 plus 8, 5 plus 7, 6 plus 6, and so on. These are the 2-digit numbers which X can be. So X is one of these. All right. So if you want the 2-digit number to have the digit sum 12, then it will have to be this. But the star of X could be 3 also. So what is X? So which 2-digit numbers have the sum 3? And the answer is 12, 1 plus 2, 21. That's a 2-digit number whose sum is 3. Remember, X is a 2-digit number whose sum is 3. And 30. That's also a 2-digit number whose sum is 3. And I think those are the only ones. You can only have 1 plus 2 or 3 plus 0, right? If you're adding 2 numbers to give you 3. So the total, the number of different 2-digit numbers which have this property, now you can count all of them. 1, 2, 3, 4, 5, 6, 7. Answer is 10. There are 10 numbers which have the property that the double star of X is equal to 3. Right? So you have to think about this, you see. You have to think and understand what this means here. Star of X, sum of the digits of the positive number. And this part here is very important. When you're taking the double star of X, it means that the sum of the digits of star of X, because that's inside the brackets, the sum of the digits of star of X is 3. And once you do that, then you will say the sum of the digits of star of X is 3. Then what is star X, right? Then you look at all those numbers will have the property that the sum of the digits is 3. And you'll see that you get all these things. And then you can eliminate very quickly 2 of these, because this one here you might not have noticed. that the largest possible value for star of x is 18. You can't get that. Or even if you keep the star of x is 21, then you look for a 2-digit number which has got property that the sum of the digits is 21, and you would have eliminated it. It's not possible. Or the sum of the digits is 30 in a 2-digit number. That's not possible. You could have eliminated there without having to go through this process here. So there would be no x's, but in these you've got, for this you've got 7 possible x's, and here you've got 3 possible x's. All right, so that takes care of the problem number 19. We are going to problem number 20 now. The diagram shows 2 overlapping circles, A and B. So you can see these are 2. They look more like ellipses. But anyway, they're supposed to be circles. The shaded area is 65 square meters. All right, in other words, the entire area of the entire yellow part is 65. Right. Well, the overlapping area is 15. So this part here in between is 15. Okay, so let me record the information as we go along. This is overlapping area, so this is 15 here. Right. So we don't know what these are, but this is overlapping. This is not overlapping. But the entire shaded area is 65, whole lot. So okay, what else do we know? The ratio of the area of circle A, this is a larger circle, to circle B is 3:2. So this area here divided by the area here is 3/2. Now, how many square meters is circle A larger than circle B? Well, we don't know what these areas are. We only know this area here. So there is an unknown or a couple of unknowns. These 2 are unknowns here. So we better give them names. Once I give names to these unknowns, then I should be able to use this information, the ratio. I can say this area would be 15 plus that, and this area is 15 plus that. And I'm going to take this area and put it over this, I got 3/2. I'll have an equation, right? Because I'll say that's equal to 3/2. So we have to give names to these 2 unknowns, right? So what I'm going to do is get to the next thing here and do the calculations. So I'm going to give names to the 2 unknowns. So I'm going to call this part here X. We already know that this is 15. Right. Now you know that the entire shaded area is 65 when you add all 3. Now, when you add all 3, you get 65. So what if this part here is X? What is this moon-shaped thing? It'll have to be 65 minus the sum of these 2. Because all the 3 pieces together give you 55. So 2 of them, you know, so the third one can be calculated, and that is 50 minus X. 65 minus 15, you got a minus X. So this is 50 minus X. Right? I would have done it mentally. I would have put an X here, and I'll say I have the total answer is 65, so there should have been a minus X here, but the answer doesn't have an X in it. So I'll put a minus X, and the other 2 numbers will have to add up to 65. If this is 15, so that will have to be 50. I could have done it mentally, but this is the other way of doing it. Okay, now they say that the ratio of the areas of A and B, area A over area B, is, what is the area of A? we say it's given that it's 3 over 2. But now we know the area of A because we can find it in terms of x. It's 50 minus x plus 15, and that gives you 65 minus x. That's the area of A. The area of B is 15 plus x. 15 plus x. And that gives you 3 over 2. So there it is. You've got an equation, right? And you can solve for x. I'm just going to do this thing very quickly because after this it's easy. If you cross multiply, you get 130 minus 2x equals 45 plus 3x. 5x is equal to 85. I think x seems to be 17. X is 17. Solve for x. Okay, cross multiply and bring all the x's to one side and so on. So I'm not going to do that because that is easy. All right, let's just get on to the next problem. There was another way of actually doing it. This 15 occurs twice. It occurs there, it occurs there as well. And altogether, you've got 65. The whole area is 65. So it's the sum of the areas must be 65 plus 15. So there was another way of doing this thing, because it's the sum of the two areas will be 60, that plus that plus that, but this is counted twice now because it's part of this and it's also part of that. So the sum of the areas would be 65 plus 15, which is 80. Oh, we didn't answer the question. The question was, okay, let's not come to that straight away. So the sum of the areas is 80, and you want to split that up into the ratio 3:2, because the ratio of A to the ratio of B is 3:2, and you're going to split the total area, which is 80, into two parts, so that one part is 3 and the other part is 2. So it'll be, one part will be 3/5 of 80. And if you calculate that, you're going to get 48. Right? 5 goes into 80 16 times, and that is 3/5, and the 2/5 will be 32. Okay. So where does the 17 come in? The question the question was not find what this part here is. There was another question. So I've broken my own rule. I said always you must know what the question is. By how many square meters is a circle A larger than circle B? So we needed to work out the area of A and the area of B, and then find the which is large, or by how many is it larger? So the answer would have been 48 minus 32. Because the area of the larger is 48, the area of the smaller is 32, and that gives you 16. So that's the answer, not 17. The 17 was here. This was 15. Remember, x was 17, right? And then these two together give you 32, and all together you got 65. So this will be 33. 32 plus 33 is 65. So this area is 33 plus 15, which is 48, as you can see. And this area here, 17 plus 15, which is 32. So this area here is 16 larger than the smaller area. I should have finished off that problem by answering the question, and I didn't. I crave your indulgence for that. We are just found the 17 and stopped there. I should have finished it off. Anyway, so there are the two ways of answering that problem. And here, in this, we are saying that when you add these two areas, you're adding the shaded part plus this part here again, because this belongs to that, it also belongs to that. Okay, so that was the issue regarding okay, now we're going to problem number 21. It says here that the diagram shows a rectangle inside a semicircle. The rectangle just touches the side of the semicircle. Well, as you can see here, two lengths are shown, the 4 and the 1. Determine the area of the rectangle in square centimeters. They give you this, and they give you this. And they want to find the area of the rectangle. So let me go into a bigger space here. So the question is to find the area of the rectangle. So what I do is, since I'm inside a semicircle, I actually join the radius. See, I've taken the center, and this is the radius of the semicircle. So I'll go up there. That's the radius. This part here was 4. So when so this was the original rectangle here. All I've done is just join those two. And now I've actually got a right angle triangle here. But this is also R, because the radius from the center to the boundary will always be the same. So this is R, and this will be R. And this part here is 1. So if the whole thing is R, that's why this part here will be R minus 1. Right. Now, once I give a name to the radius is evidently a character that occurs in this problem because you've got a circle, right? So I draw the radius and then fill in this picture as it stands. And just remember what we need to do. As I always said, what is the goal? To find the area of the rectangle. Okay, what is the area of the rectangle now? We've got the height of the rectangle, or the breadth if you like. It's 4. But the length, you got R minus 1 here. So it's equal to 4. Let's say breadth times the length is 2 into R minus 1. Because by symmetry, this part here is also R minus 1. And this part is 1. Right? You're drawing a rectangle inside a semicircle. So you will have that these two should be the identical. This is just a mirror image. So you've got 1 here. So the area that you are looking for is length, which is twice R minus 1. Because this part is R minus 1 multiplied by breadth. So we are looking for this thing here. What is 8 into R minus 1? So in other words, I need to find R. Then I'll be able to calculate the area. All I have to do is to substitute inside here. Can I find R? Now we've got Pythagoras kicks in. And you've got that in this right angle triangle, you got 4 squared plus R minus 1 all squared. The sum of two sides of a right angle triangle is equal to the square and the hypotenuse. Right? Pythagoras gives you the equation that you're looking for. And if you solve all this, you got 16 plus r squared minus 2r plus 1 equal to r squared. Right? This is r minus 1 all squared is r squared minus 2r plus 1, the square of a binomial. The r squares cancel off. And you got 16 is the 2r. If you bring the 2r to this side, you got is equal to 17. So 2r is 17. So you need to get, you see, if you want, you can put r is equal to 17 over 2 and substitute 17 over 2 into this, and you'll get 8.5, 7.5, I think you get 60. It doesn't look like the answer, but something like that. So you can substitute, you can do it like this, but if I want to avoid fractions, I can just leave it here like this. This is 4 times 2r minus 2. 2 into r minus 1 is 2r minus 2. 2r is 17. 17 minus 2 is 15. And 4 times 15 is 60. Right? So I could have done it this way without any fractions, because I've got a 2r in this equation. I've got a 2r, and I know what 2r is. So I can substitute for 2r rather than r. But in both cases, you'll get the answer 60. Okay, so this problem here, you can see all you are given is that, right? And if you just look at this now, you wouldn't be able to solve this problem, because you need to find this part here, right? All you know is that this part here is 1, and you don't know this part, because to know this, you need to know the full diameter. And to know the full diameter, you need to know the radius. And that is why it's very important to draw the radius. And that's why we drew the R. Because we could have argued it like this. We say, hey, I need to work out the rectangle, the area of the rectangle. I've got 4, but I don't know this. I do know this is 1. Now, how do I find this? Now, to find this, I need to know the full length, because I've got 1 here and 1 here. But the full length is a diameter. How do I find the diameter? Well, I need to know the radius. Right? So let me draw the radius. And that is where this line features. And once you do that, then after that, you can solve the problem. Okay, so let's just get on to the next one. Determine the sum of all integers x which satisfy the equation. You've got a funny looking equation with an exponent in it. Right? 218 minus x raised to 221 plus x equals 1. And you got to solve for x. Now, this is one of those situations where you say, I don't know how to solve for x. We know how to solve for x, bring all the x's to one side. Or if you've got a trinomial, I know how to solve for it. But now, there's my equation. But x is an integer, you see. So this is a very important fact here. X is an integer. And the sum of all the solutions. So this is the goal. Find the sum of all the solutions. Right? Remember that I told you, you have to find out what the question is. So we need to work out each of the solutions. I've got no escape. Okay, so now you have this number raised to that number is equal to 1. Now, what are the possibilities? Well, the first possibility I see is that the exponent must be 0. Any number raised to the power of 0 equals 1. Right? Now that, I'll use the sign implies, always like to use the sign. This, if this, then this. And here you can solve for x. X is minus 221. So you've got at least one solution. This is where the exponent is 0. All right, now when you take an integer and raise it to some power and the answer is 1, what is the other possibility? What are the other possibilities? The other possibility is that the base itself is 1. 1 raised to any power is 1. So let's have a look at that, where this base is 1. Right? In this case here, what is x? You can solve for x. 218 minus what gives you 1? It's 217. So x could be 217. And I think most people will probably stop. A lot of people will stop here. They'll say this must be 1. And they say x is 217. Then some people might notice, hey, the exponent could be 0. But the sharper people will say, this base could also be -1, because -1 raised to 10, for instance, is plus 1. So this base could be -1. It can't be any other thing. If you put 2 or something, 2 raised to any power can never be 1. Only 0. But we have taken care of that. So what can the base be? The base could be negative. So this can be negative, but if this is -1, the exponent will have to be an even number, because if this exponent is an odd number, -1 to an odd power means you're multiplying -1 by itself an odd number of times, and the answer will be -1. -1 to an odd power, like -1 times -1 times -1, right? Each time you have a pair, it becomes +1, right? And then if you have an odd number, you'll always have 1 left over. So you'll have -1 to an odd number is -1. Okay, so let's just see what happens here. 218 minus x is equal to -1. In that case, bring the x to one side, you got 219. 218 minus 219 is -1. Okay, now will that give you a solution? So if x is 219, what happens to this? We want this exponent to be even, right? Because otherwise it's -1. But if you put x as 219, and if you take this exponent, you got 221 plus 219, and that is certainly even because it's sum of 2 odd numbers. So if x is 219, right, then you will have -1, 218 minus 219, and the exponent will be 240. And that is certainly 1, because that's an even number. So these are the 3 solutions. And you want to, the sum, the only 3 solutions, the only 3 possibilities. The exponent is 0 or the base is either +1 or -1. Now you need to add up all these things. So when you add all these things, I think you get 215. So that's the answer. Okay, so you have a sort of non-routine equation, and you have to use logic or your common sense to decide what the solutions are. But remember, x is an integer, right? So which integers satisfy this? You can have +1 or -1. That's the only integer base which will give you +1. Right? No other integer base will give you 1 as the answer. So you can have this +1 or -1, or that equals 0. Those 3 cases give you 3 solutions. Add the 3 solutions, and you're on your way to the solution to the problem. Okay, now we are at problem number 23. Problem number 23 says that Tom was jogging at a constant speed of 10 kilometers per hour along a straight road. So let's draw a diagram. There's your road, and Tom is jogging along. And he's traveling at 10 kilometers per hour. T for Tom is going on a straight road, maybe in that direction. He's traveling at 10 kilometers per hour. Although in 1 hour, you will cover a distance of 10 kilometers. That is what you mean. In 1 hour, it covers a distance of 10 kilometers. A Jerry at a constant speed of 12 kilometers is behind. He's 600 meters behind him. So Jerry is here, 600 meters. He's behind Tom. He is also traveling in the same direction, but he's traveling at 12 kilometers per hour. How many minutes will it take Jerry to catch up with Tom? He's traveling faster. He's traveling at 10. He's traveling faster. So evidently, if they keep at the same speed, there'll come a time when Jerry will overtake Tom. And the question is, how many minutes will it take him to overtake? Just as an aside, there's an error in this problem. I don't know how many of you can see it. The error is that in Tom and Jerry, Jerry is the mouse and Tom is the cat. And why should the mouse be chasing the cat? Somebody who created this problem, got his names upside down. Anyway, in all these violent comic strips where Tom is chasing Jerry, you have the cat is chasing the mouse. Anyway, whatever the problems are, yeah, Jerry is the cat, the mouse is switching roles here. So let's just get back to this problem. You've got, there are 2 ways of doing this. The one way is a kind of clever way. You see, if this guy is traveling at 10 kilometers per hour, this guy is traveling at 12 kilometers per hour, right? To catch up with him, he's 600 meters behind. And you can ask the question, how long would it take him to cover 600 meters if he's traveling at 2 kilometers per hour? Because he's traveling, suppose they both stop, right? Yeah. And this is 12 and this is 10. So if they both stop, then he will be traveling at 2 kilometers per hour in excess. And so one way of doing it is, let's just get to this. I'll get to my diagram. Okay, so one of the ways is, so here is the question. How long? That's the question. How many minutes will it take Jerry to catch up with Tom? How long will it take Jerry traveling at 2 k's per hour to cover 600 meters? That's one way of doing it. Right? It's a clever way. So if you're traveling 2 kilometers in in 60 minutes, that's 2 kilometers per hour in 60 minutes. You want to cover 600 meters, 600 meters in how many minutes? So that's the question. So we have to convert both to meters. 2 kilometers is 2,000 meters. So let me just make this thing 2 kilometers, 2,000. And then it just becomes a simple ratio problem. This becomes 2,000 meters in 60 minutes. So to cover 600 meters, it will be 600 over 2,000 times 60. This is 60 minutes. And then if you take those 3 zeros and you make these 3 zeros and 2 goes into 6 3 times, 3 times 6 is 18. You're not allowed to use calculators. So very often you do all these things by taking fractions and canceling common factors and simplifying. You can do a lot of multiplication and division using fractions. And you will see more of those examples. So the answer to the question is 18 minutes. Okay. Right. But this is using this method here. If you think that Jerry is traveling at 2 kilometers per hour, then all he has to do is to just cover 600 meters. But if you didn't see that, then we'll have to look at this thing. The answer is 18 minutes that we just have seen. We could have done it another way. All right. So this guy is traveling, and suppose they meet here somewhere. J and T are both at the spot. Jerry just meets Tom at that moment. And of course, that's the end of Jerry. That is provided Tom is hungry enough. Okay, now the question is now, how many minutes will it take Jerry to catch up with Tom? So what's going on here is that at this stage, Jerry, in other words, is traveling for a certain number of minutes. We don't know how many that is, right? So let's just draw another line and say, this is your timeline. This is T minutes, or make it T hours, because you are given kilometers per hour. So suppose it takes him T hours to catch up with Tom. Now remember, takes him T hours, but Tom also takes T hours. Now this is an interesting thing, because both of them are meeting at that spot. So this fellow also takes T hours. To reach the spot here. Okay. Now we go into the distance line, because if he's traveling at 10 kilometers per hour and is traveling for T hours, how far would he have traveled? 10 kilometers in 1 hour, in T hours, you'll take 10 times T. So this is 10T. This distance is 10T, because he's traveling at 10 kilometers per hour and is going for T hours. This distance is 10T. Right. So the distance from J, this total distance will be 10T plus 600 meters, but you have to be careful here. 600 meters is 3/5 kilometers. We're working in kilometers here. 10 kilometers per hour. So you have to translate this into kilometers. 600 over 1,000 is 3/5. And that is equal to, this guy is traveling at 12 kilometers per hour. He's also traveling at T hours. So he would have covered his speed at 12 hours 12 kilometers per hour. In t hours, you would have called 12t. So this 12t is the same as this distance plus that distance because they are meeting at the spot. So here you have an equation which is much more difficult to get if you think about it. If you think about it, this is logical. Make sure you convert meters to kilometers or kilometers, meters, whatever, the same units. And now you got an unknown. Remember, t is in hours. So you've got 3 over 5. 12t minus 10t is 2t. That is 3 over 5. And therefore t is equal to 3 over 10. That is hours. And in minutes, the question was in how many minutes. So that's 3 over 10 times 60 minutes. 10 goes into 66 times. 3 times 16, 6 is 18 minutes. Lo and behold, we come to the same answer as before, but in a much longer and complicated way. If you used a little bit of, put your thinking cap on, you will see that it would have been much easier to solve the problem in that first method. Okay, that took a long time, and I'm almost at 6 o'clock. Let me see what I've got here. Okay, I'm going to do the last two problems. Those who want to go, you can go. But I want to finish. We have problem number 24. I want to do this. I want to do this quickly. Problem number 24. It says the following. You got a clock. But this clock works correctly, but the numbers are missing and the clock has been rotated. So you don't know where the 12 is and where the 1 is and so on. But you know, if the 12 is here, then this is 1 and that is 2 and that is 3 and so on. It's been rotated. Using the positions of the hour and the minute hands, or use the positions of the hour and the minute hand to determine which hour is represented by the letter A. Now this problem here, if you have not tackled it, hopefully you have tried this thing and failed. You'll try all kinds of things. And as I did, I must tell you, I took a long time to solve this problem. But eventually I found a very nice solution. By looking at where the hour hand is going exactly onto that line there. Let me show you that. Hour hand is pointing here. This is hour hand. And this, everything is moving clockwise, obviously. It's a clockwise. It's a clock. Okay, so in other words, this is the hour. Okay, so you've got the hour hand is at that spot. And it has only moved 3 minutes past the hour. The hour hand has moved 3 minutes past the hour. That is the key observation in this thing. The hour hand has moved 3 minutes past the hour. To move 5 minutes past the hour, it takes 60 minutes. You know, the hour hand, it travels slowly. It goes from 1 to 2, it takes 60 minutes. From 2 to 3, it takes another 60 minutes. So to go through 5 of these units, it would have taken 60 minutes. But it's gone to 3, so it must have gone through 3/5 of 60. The number of minutes past the hour hand is 3/5 of 60, which is 36. So it means that this time here is something 36, right? Before it gets to the next hour. So if it's something 36, now you know in your ordinary clock, when you got something 36, the 36 would be here. The 12 is here. 6 is here. 7 is here. 8 is here. And 36 would be here. So the minute hand is here. See? So this is where the minute hand is. Now you can see this thing is going on. So that means it's 7. The time is 7 something, 7:36. The time is 7:36. Because the minute hand is here. Right? So this number here, it's still going on, right? This number would have been 8. To say the time is something 36, it means it's down here. And the minute hand will be here, somewhere like that. It's at least the hour hand. Okay, so if this is 7:36, it means that this must have been 7. No, I'm sorry. Yeah, these numbers are all wrong here because they're all rotated. So it's moving towards 8. The hour hand is moving towards 8. Right. So the next hour would be 8. Okay. Okay. And then finally, the last question. This one here will take a little bit of time, but I'm just going to give you discuss the question first, and then what's going on here is that you got a rectangle which is 10 by 6. Let's just record that information. This is 6 here, and this is 10. Right? It's divided up into 5 smaller rectangles, which is 2 by 6. So you got 2, 2, 2, 2, 2. Right? So you got 5 2s here, and this is 6, so you got 5 smaller rectangles. The diagonal AB is drawn, right? As well as a number of smaller diagonals. Okay, so as you can see, all these things are shaded like this. How much larger is the shaded area than the unshaded area? Okay, now the way to do this is I need to calculate the area of the shaded part. There are 10 pieces here. And once I know the shaded part, I know the full area because it's 60. Then I have the unshaded part, right? Then I can calculate the shaded part and the unshaded part, and how much larger, I subtract the two. So I need to calculate the areas of the shaded part. That is the goal now. You know all these right angle triangles. So in all those cases, you've got one side, you've got the base, but you don't know the height. These heights are moving, getting bigger and bigger and bigger. All right. So we have to ask ourselves, what is the height? Let's take the height of the smallest triangle. We don't know what this height is. Let's call the small height here x. Now you got these two are equal pieces here, 2, 2. So this height here is 2x. See? And the next one will be 4x, this height. And the next one, oh, I'm sorry, 3x. Right? And the next one will be 4x. And the next one will be 5x. If the smallest one is x, if this height is x, then because all these are equal, the The heights go in the same, they get double. You see, this length here is 4. That length there is 6. That length there is 8. That length is 10. So these ratios will still remain the same. So you got x, 2x, 3x, 4x, 5x. And you got exactly the same setup on this side here. At the bottom, you got the same setup as the top. So what is the shaded area at the top? Now look, 5x is this. So 5x is equal to 6. That's immediately you know what x is. Because when you move from x and go up there, 5x is that. So 5x equals 6. That gives you an equation. So you can solve for x. And the shaded area, I'm doing this quickly. This is going to be half base times height with this triangle. So it's half. In all the cases, all are triangles. So it'll be base times height. And the base is always 2. So I'll put the base, half base, the 2. And I just have to take the height out. The height is x plus 2x for the next triangle, the next shaded area. The next one is 3x. The next is 4x. The next is 5x. And that is the area of the top shaded part, right? The bottom shaded part will be exactly the same because you'll see that this piece is the same as that piece is the same as that, and so on. So you have the bottom part is exactly the same as the top. The top is just a repetition. So but then you'll have to start with this as x, and then 2x, 3x, 4x, and you go up to 5x again. So you have to multiply this by 2. This 2 over 2 is 1. So your shaded area is 2 into that. And when you work out all this, you'll get 30x. Because 5 plus 4 plus 3 plus 2 plus 1 is 15 times 2. So this is a shaded area. Right, it's half base times height, and then you double it to get that. So that is, and remember 5x is 6. So 30x is 36. 5x is 6. So this is 6 times 5x. So the shaded area is 36. The whole area is 60. So unshaded will be 60 minus 36, which is 24. This is your shaded. And the question is, how much larger than the shaded area is the unshaded area? And the answer is 36 minus 24 is 12. So the trick is to ask the question, how do you find the area of the shaded part? The area, they're all triangles, right? First answer. They all got the same base, second answer. So therefore, you just need to know the heights. But you can look at the heights. You can see the heights are, they're forming a nice sequence, yeah? So take the smallest x, and then each time it just becomes one more. And then that part you have to understand why that is happening. You have to think about that. And then once you got that upper shaded region, then you got the lower shaded region. And then you just double that area. And I've done all that together. And then you got your shaded region. And then therefore you got your unshaded region. And you can work out how much larger the unshaded region is. Okay, thank you very much. I've come to the end of this, and it's 12 minutes past 6. I must apologize for having gone beyond the time, but I've got to finish everything as quickly as possible. Now, again, it's going to, I think in days to come, I'm going to reduce the number of questions that we can, we don't have to do the easier ones. All right, so at this stage now, what I want to do is I'm going to stop the share, and I'm going to stop the recording.
And there you have it. Another Olympiad training session with Professor Pillay. Remember, practice makes perfect.